Hi and welcome to DCO. If you're new here, my name is David Copete. What you'll be seeing in this video is a follow-up, which is going to show you how to take that design that we created for the ceiling and the array and how to stagger it to be able to label the design as well, and then be able to set it up so you can fabricate it. So this was a question that I got from the last tutorial. I'll have that one also attached here. But if you are excited to learn a few more tricks, a little bit more about how parametric design works, this one's a little bit more advanced, but I'm sure you'll learn something new. So thank you for being here, and let's jump right in. So the first thing we need to do here is figure out which ones are the surfaces that create this whole array. So what we'll do is go back here and look for the portion where we create the array. So that's going to be right here at the boundary surfaces that were created from the contours. So I'll take that and I'll actually move the script down here, and I'll be creating the next portion for fabrication up here at the top. So I'll take these, and the first thing we need to do is, so we don't have a conflict between the design and the array that we're going to create for fabrication, what we need to do first is move this out of the way. And so we'll bring in a move component. We'll plug in all of those surfaces that we use to extrude into the geometry, and then use a Z vector to move this up. So I'll change this here to whatever number is enough to make sure that we're clearing the design here. Why? Because we want to be able to still look at the design, be able to make changes, and then have this right above. The next thing we'll do is take these and move them up and step them up so we can look at it here in, well, typically this would be the right. And we want to be able to step them up so we can see them here. So what we'll do is take this, bring in another move component. Then, since we're moving them all at once, similar to what we did here, what we need to do now is step them. So we'll bring in a series component. The step amount is going to be approximately the maximum number between the top and the bottom of this. So we can change that. We'll create a slider here. Now we need to move it in a Z direction, so it moves them up. And the count is how many of these do we have. So for that, we'll use a list length. And what this component does is whatever you plug into it, it'll give you the number of how many you have, as long as you have it in one list. So I'll flatten it here just to make sure. We'll have 39. So we'll take this length, plug it into the count. And so now we have 39 numbers that's stepped by 24, and we can plug this into the motion. Now notice that they're still overlapping, so we can increase this to make sure that the ones that go the lowest clear the entire design here. And so we're looking at this from the right side, from the right view. So if we go here to perspective view, you'll see that we've done nothing more than just take those and move them up vertically. So at this point, we can go back to our initial set and hide it. So now you're seeing that we've organized it so we can see it from the side, and then we can take these and put them into a sheet. But the idea here is going to be, how do we make sure that we know which one of these is the ones that we have up here? So what we're going to do right now is label these first so we know how they're organized, and then be able to label those up here on the outlines of the contours. So what we need to do is go back to the design, and we'll hide everything except for the surfaces that create it. Now we can use this one, but I'm actually going to route it through a surface component and use this one here. So now we'll hide that one because it'll be redundant. Now here what we need to do is pick a side where we want to label this. So I'm going to pick here one of the corners. So it'll be, I think, this side. What we need to do is take those surfaces and deconstruct them so we can pick the points at each of these corners. So I'll go here to deconstruct. Now I'll pick one of these vertices. So notice that we only have 4 for each contour. And so we'll go here to list item. It's picking these down here. We want to keep them consistent. So we'll change the index. We'll go here to, well, it'll be from 0 to 3. And so that's 0, 1, 2. And we'll hide the entire thing here, or the deconstruct brep. Next, we'll take these points and move them here in the positive Y direction. So here's the thing. Depending on how you have this created, so if you have this done in the X direction, well, this is going to be moved in the Y direction, but we can also do this. We can also create a plane at every one of these and be able to use one of these. So let's do this. We'll take one of the planes from here. So I'll copy my list item, plug in the faces, and now I'll flatten the input. So I'm just picking one of them. Then what I'll do is I'll create a reference plane by using evaluate surface. And the point is going to be, well, we'll take the surface and reparameterize it. And the point is going to be in the middle. So we'll go quotations 0.5, comma 0.5. So now with this reference plane, you'll see that this is going to be the X direction. This is going to be the Y direction, and the normal will be the Z. So what we need to do now here is deconstruct that frame, but using deconstruct plane. And now we can move it in the negative X direction. So we can use that vector. We'll go to amplitude, plug in the X-axis into the vector, and the amplitude is going to be by how much. So what we need to move is these points. We'll create a number here of 1.5. And notice it's going in the positive direction, so we'll actually change that to negative. And move this over, so this is actually 2. Move this one over to the right. So now we can hide this. And we've created this point so we can here on the right hand side know how these are going to be labeled. So in this portion, I'll be using a dot, which is going to be like this visual location of where these are and their organization. So here we'll go to a dot or annotation dot, and this is going to be the location. Now here's the thing, we need to flatten the input, otherwise it's going to look at those as individual points. And we want it to look at one long list. We'll go to the height, the text height. And now we're going to bring in the text. So what's the text going to be? This is going to be 1, 2, 3, 4, 5, all the way down to the end. So to do this, we need to know how many we have. So that's going to be here in list length. And I'll actually just bring in a panel so you can see it kind of visually here how many we have. So we have 39. How do we create 39 numbers that are stepping by one? We'll create a series component. We'll plug in 39 into how many? Into the count, stepping by one, and starting at 1. So by doing that, we have 39 numbers, stepping by 1, starting by 1. And if I copy this panel, you'll see that we have all of these here. Starting at 1, even though 0, this would be 0 if we didn't have this. But 0 is not a number that you want to have for how many subdivisions or how many of these we have. So we'll use this and plug that into the primary text. So I think this one, we'll change it to a range of 0 and then have this be a larger number. Now we can also use something other than a dot, but I think this is visually a good way to show this. So let's move this back this way. Now what we need to do is take the text for all of these and place them here, either on this side or on this side. Now what happens here is when we create a projection or a make 2D, we're going to be using the right side. So what I want to do is make sure that it's here on this side. And so there's a few things that we need to set up. The reason why is because we'll be using this, we'll be using the point here at the top, move it down to the left, and that's going to be the location, but we have to be able to view it from the right side. So we'll do basically the same thing that we did to this bottom part, but we'll be doing it to this top one. So what I'll do is I'll hide all of this. And now with this one, it's a little bit easier to see because they're kind of staggered. So let's do this. Let's deconstruct all of those planes, and let's pick this top right again. So if I'm not mistaken, how we did here is if we copy that, plug in the vertices, you'll see that we have this here. Now, if we want to, we can use some of the steps that we use down here, which are going to be this plane, and be able to move it in the positive X direction where this is deconstructed. So I'll copy this over. And take this point, we'll bring this back and move it in that direction. Now the point needs to be moved down. So let's use this slider to move it over, and then to move it down, we'll bring this, a Z vector, and a negative component. So now we have this and these 2 points. Now we can hide. So for what we're setting up here is the text on surface component, which need a few inputs. First is going to be the baseline, then the base surface, and all of the inputs that you see here. So the depth will make it 0. We know that. Although it's useful sometimes to have for it to have a depth because you can subtract from the object. Now we won't need that here because technically we're going to be doing a make 2D, so it doesn't need a depth. It's just going to be a surface. And we're looking at it from this side. So let's scoot this back to here. What we're going to do is create a line segment to the right. So it's going to be taking this and moving it relative to this plane. So we're going to be moving it in the positive X direction. So I'll copy this. We know it's going to go in that vector with a different amplitude. So I'll copy this. And so we've created 2 points. Why? Because that's going to create the line segment where the text is going to be centered. So starting here, ending here. That's going to be the baseline. Notice that it's upside down, so we need to change the orientation of that. And the way to do that is going to be to create the surface. So now we'll take this point and move it up for the height. And we can use the same vector here, or the same number. Now this needs to be plugged into this one. And it's going to be positive for up. So basically we've created these two points. And now we need to connect this one to this one with a line segment. So using this as the input for start, this one for the end. Now we can extrude this line segment out this way to create the plane. So extrude, and instead of direction, we'll use this line. Now that extrusion will be the base surface. So what this does is gives it the correct direction, which is going to be looking from this way. But now what we're seeing is that the text is wrong because the baseline needs to be flattened. The base surface needs to be flattened as well. Now the depth is going to be 0. That's fine. And now the text. Well, the text we've already have done here because we've created a series here from 1 to 39 or however many we have. So we'll take this, bring it over to the text. And so now we can control with this one where that text is located in terms of that box will be the overall location. It'll be centered on that line. So we can kind of hide this surface and these points. And you can see that this line segment is really what determines where that's centered. Now, of course, we can also scoot this over up. And with this one scooted back to the beginning. Then we have the height for the font. So we'll go, say, 1.5. And when we look at it from the right side, here we have, well, the length here we need to increase because it'll actually shrink it to be like that size. So maybe we can use the text font and this one to be the same. Now notice that if we increase the depth, well, it's going to give it some thickness, and we don't need that because these are going to be planes. So let's go here to 0. So we've got the first one all the way up to the 39th one, and we can change back here. If we go back to the design, we can change the distance. So if the contour spacing is 6.2 and we changed it to 8.2, well, now we're going to have less. We have 29 of them. They are still all organized here. And so that's really the power of using a parametric tool like this, is that when you change the design, it can change also the way that you have it organized here for your sheets. All right, so we're almost there. We've got the text here as a surface. We'll flatten this. We've also got the array. Let's see where that is. on this one and this one. And I'll bring that out with the surface component. This is an empty component, which means it has nothing. You can set one, or you can also use that to bring things over and just know that it's in here. We can also hide the wire display. And so the cool thing about this is that now we have the contours down here. And we can bring back the design. So now we know how they're organized. I'll actually scoot this over a little bit more. Okay, the next step is going to be taking these from this location, which are, this is not ideal, and bringing it to the ground. So inside of Rhino, typically you would do that by doing make 2D. And so that's going to be the next step. All right, so this part we're going to do make 2D. And there's some things that are a bit strange about making 2D here in Grasshopper. And I've had a bit of some issues here. And let me explain to you what I've been able to figure out. So first things first, we need to pick a view in which we can make 2D. So here we'll go to view, bring in this collection of frames or this view component. And when you right click, you can go here to write. Next, we need to bring in the make 2D component, which is the one that I'm using. Then a parallel. So we'll go here, make 2D parallel view. Now I'll use this view to plug into the view here, and then use the contours as the input. Now with this one, it's going to ask you to compute. So what I'll do is I'll go to compute here, and notice that they show up down here. But there's an issue. Here's the thing. I'm going to copy this and do the same thing of make 2D to the numbers. But what happens is it's bringing them in backwards. So even though we set it up so when we look at it from the right, the number should be correct, well, we have both the contours and the numbers flipped the complete different direction. So what I'll be doing here is showing you the thing that I did to fix that. I'll change this view, which the views in here that are contained in this component are going to be the views that you have on your viewport. So I'll go to set view to left, center this here. But notice now that when we do make 2D like this, it's not going to work because it's not intersecting with this view. So now what we got to do is move this over, move this view in the X direction, because that's the way that we'll create the contours. And so let's move this in the positive X and move it so it intersects with this. And now we'll be using that. So I'll create a relay, use this view as the one that we move, and these two that go into the two different views as the input. That seems to fix the issue here. So here we have from 1 all the way out to 29. Now it's overlapping with, so I'll hide all of this. It's overlapping with our design here. So what I'll do is I'll move all of these in the positive X direction. So I'll copy this over again, that portion of the movement. Move the contours, and then move the numbers. So now we've created the contours here on the ground, and they are labeled between 1 and 29. We can always change the design if we want to. We can change the overall size. But the idea here was to create a script where you can take a portion of your design, stagger it so you can see how it's organized, and create a list of numbers between the beginning and the end, and be able to project that onto the ground here. So then if we wanted to, we could create a surface between these two. So what you'll see, if you got lost somewhere or you want to see how everything was plugged in, you can go to my website and download this for free until the next video is posted. But the idea here was to show you a bit of the workflow that I take for deconstructing some of these designs. Now, I don't do this as much as creating just parametric design scripts, but I'm showing you a bit of a workflow that works that is separate than using OpenNest. Now you can, if you have OpenNest working in your Rhino 8 or if you have Rhino 7, you can take these surfaces and nest them into a sheet. Or you could also just bake this and then be able to arrange them so that they fit within a sheet, and then be able to cut them, whether it's with a CNC or a laser cutter. All right, so at the end of this video, you're going to see me cleaning up the whole script so you know and have everything labeled. So one of the things you'll see here at the end is going to be the contours on the ground, the contour shifted. But here's one thing that I did not go over, and I feel like it's one that is not necessarily critical for the script, but I wanted to share with you that trick. So here, where you see font, we didn't plug anything in, and by default, it says sans bold, no italic. So I'm going to show you how to be able to change the font to be one of the fonts that you have in your computer. So first thing we'll do is bring in the font list or the font table. Now it's a bit of a different looking component because it has no inputs. All it does is in here, if we bring in a panel, we're going to see that it has a big long list of all of the fonts that you can use. And it's all of the fonts that you have in your computer. Now here's the thing. To be able to pick one of those, all we need to do is bring in a list item, plug in that list into the list item, and then with the index, we'll go from 0 to, I wonder how many we have here, 271, between 0 and 271. And now you can cycle through those. So let's go here, plug this one into the font. And I'll also do that to this one here, so they're consistent. Now, notice that nothing happens, but if we change this here, it's going to start changing the font For now, we'll go 1, 2, 3. We'll keep it here at 3, or I can even keep it here at 0. I just wanted to show you how you can change that font as well. So that's going to be for this one. And I like to go to wire display hidden so it doesn't overlap and make things messy. So now we have this list. We don't even need this panel, but it's good to be able to see in which one of those you want to pick. And then the number is going to correspond with the item that you're going to pick. So I just wanted to show you that here. We can compute that part as well. And so I'll have this available, and I've mentioned this multiple times, for you to download and see how the things were plugged in. I do want to share with you also the entire script, so you'll see the entire script from the previous tutorial. You'll also see this part. And what I like to do here to show a little bit of a difference between what was from before to what's there now, I'll right click here, change the color to white, and then the opacity, change it to 100. So this shows you that this is going to be a bit of a separate portion, but we're using the contours from that surface. So this is going to be fabrication script. And you'll also see me cleaning this up for your use.